All right, so there are two different types of problems in this problem set. They're very similar. I want to start with this type of problem that you see on your screen first. This is sort of the easier setup in my opinion, and then we'll move on to one of the ones that are a little bit trickier. Okay, so both of these are asking you to find the secant slope, the slope of a secant line. And the way we're going to do that is our average rate of change formula, right? So if we have x1 and x2, it would look like this. Right? So this is going to be the slope of our secant line. And remember, you can reverse these two, so x2 can come first on top and bottom, and x1 can come second on top and bottom, as long as they're kind of lined up vertically, right? Where I see students get caught up on this is we're just filling out a table from a function, which you already know how to do, but there's this like extra step of plugging it into the formula, right? So what I want to do is actually make a separate table. You don't necessarily have to do this on paper, but it can be helpful if you're getting lost in the process. So we're going to sort of recopy the table, but I'm going to add this row f of x2, and then I'm going to have secant slope. Okay, and I'm going to rewrite the table using the same values, just with space to plug in that x2 into f. Okay, so here are my given x2s. My f's of x2, I have to plug them into the function. The function is up here. I'm going to show you a fast way to do that in your calculator. Okay, so what I've done, right, is I've gone y equals and I've typed this into the grapher. And I'm going to let it graph first. And then I'm going to go second calc value. And then I can type in an x and it'll give me the y. Okay, so let's fill out my table. So my first x is 4, and it's going to spit out negative 64. And then I can just retype now 3.1. It gives me negative 69.58. And then I can retype it again, 3.01. Okay, negative 69.9598. And then one more. This is negative 69.996. And then we also need 3, right? Is our original value. So we'll go ahead and get that one, 3. Negative 70, I bet you could guess that. So I'm just going to make a note of that up here. F of 3 equals negative 70. Okay. Now, this information is going to help us find these secant slopes. So what goes in here is the result you get when you plug everything into our slope formula here. So we will do negative 70 for this one, minus negative 64, and then 3 minus 4 on the bottom. Okay, so that's my f of 3 minus f of 4, and then 3 minus 4. Okay, and then whatever you get here is your secant slope for that particular secant line. So it looks like I get negative 6 over negative 1, which is 6, right? And then you'll continue to do that, and the rest of these you're going to need a calculator for, right? You're going to continue to do that to fill out the whole table. Okay, so here are my results. I showed my intermediate step for the first one, and then the rest of them I just did the calculations because it got a little tedious. Make sure you have, if you're capturing this in your notes, make sure you know how I'm getting these numbers. But when you're actually solving these, it's okay to do the intermediate steps in your calculator. Okay, so my table would look like this: 6, 4.2, 4.02, 0.002. Okay. And the reason that this is useful to us is because as we take the limit, as we look at the pattern here, this suggests to us that the slope of that tangent line is 4 because these numbers on the right-hand side are approaching 4. Okay. We'll move on to another example. Okay, this is the type of problem in here. It's the same thing, but this is the type of problem in here that I find that students get a little bit more hung up on. And it's because it's presented in a slightly different way. So notice instead of giving us x1 and x2, they give us -3 and -3 plus h. Okay, so we've added just like this other little step of figuring out what x2 is. So h is sort of the length of your secant line. It's the difference between the x values. Okay, so the way you can tackle this if you're getting sort of lost in the steps is you can make a table again to organize this like we did last time. And we're just going to add one extra column to it. So I'm going to rewrite my table. Okay, so I've rewritten my h's. And then the column that I'm adding is x2. So now we have to essentially calculate the number that we were given in the last one. So x2, oops, that should be a -3. x2 is -3 plus that h value, so plus the change, right? So my first x2 is going to be -3 plus 1, which is -2. And then -3 plus 0.1 is -2.9. And then -2.99. And then -2.99. Okay? And then we're going to take these values and plug them into our function. And then we're going to calculate the slopes. Okay, so I've plugged in my x2 values in the f in this column. Remember, f was up here, right? And I can use that trick I just showed you on my calculator to find those. And then my last step is going to be to use that slope formula. So slope formula is this. That's the slope of my secant line. And we also need, of course, f of -3, so let's find that real quick. So I'll plug that into my calculator, and we get -2 we get, right? Okay, so now I'm going to use my secant slope formula, or just my general average rate of change formula, right? And I'm going to subtract -2 minus 1 over -3 minus -2. Okay, so I get -3 over -1, which is +3. I'm going to do that for each row in the table, and that's going to get me my results, same as last time. Okay, here are my results. Notice that we always have this pattern, right? So we have this pattern as h approaches 0. In this case, the slope of my secant line approaches 2. Okay, so look for this. If you're not getting this result, this is why we're doing this. So if you're not getting this result, you have an error in your work and you want to check your steps.